Assalamualaikum. Hello. Welcome students to Let's Go Revision with me, Teacher Manisha. Before we start our lesson, I would like you guys to take a look at this video and the things that I have prepared.
Why does a pencil look bent in water? Wow, that was a very cool magic trick. Now check this out. Hey, stop crying. Your magic wand is not bent or broken. Look, it is safe. But do you know why your magic wand appeared bent in water?
In my hand, I have a bowl of water and a spoon. What can you observe when I put the spoon in this bowl of water? It seems like the spoon is bent, right? Now, you can pause the video and try it by your own. So students, this is a close-up of what I did just now. So when I put a pen, it will bend, right? Okay, I will show you the other things to make it more clear for you. When I put a fork, it will also bend. Next, when I put a chopstick, it will also bend. The other things is, when I put a straw, it will also bend. And then the last one, what if I put a key? Does it bend? Yes, it is. It will also bend. Now, do you get the idea of it? Can you guess what the topic that we will learn today? Choose either one of these, students. I will give you a hint. Refraction is like bends, while reflection is like changes direction. So which one? Alright students, if you chose refraction, you are right. Remember you saw the spoon is bent, right? In this video, we will learn about refraction of light in the first subtopic in chapter 6, Light and Optics. Have you ever wondered why this situation occurs? Let's look at the definition of refraction of light. By definition, refraction of light occurs due to change in velocity of light when traveling through mediums of different optical densities. Looking at this diagram, this area represents the air and this area represents the water. Air and water have different optical density. Hence, when light travels from air to water, the velocity of light will change, causing the light rays to bend from the normal line. Before we go further, let me explain about optical density. Optical density is a measure of how fast light travels through a medium. The higher the optical density of a medium, the slower light travels through it. In this case, we have air with lower optical density and water with high optical density. Hence, the light will travel slower in water rather than in air. To understand better about refraction of light, we will have a look at two different situations, which is the first one is from air to water and the second one is from water to air. The first situation is the refraction of light from air to water. When light travels from a medium of low optical density to a medium of high optical density, light rays bend towards the normal line. This is because the velocity of light decreases when light travels from air to water. Due to this, the angle of refraction R is smaller than the angle of incidence I. Let's do it together for the second situation, which is the refraction of light from water to air. Okay, students? When light travels from a medium of high optical density to a medium of low optical density, light rays away from the normal line. This is because the velocity of light increases when light travels from water to air. Due to this, the angle of refraction R is bigger than the incidence angle I. Alright students, before we go to the next part, let's take a quick rest. Moving on to the next part, we will learn about refractive index and why this term is important. This is because refractive index N is one of the factors that influence the refraction of light, not only the optical density. Both refractive index and optical density are related to each other. This will help us to understand how light behaves when it travels from one medium to another medium. The function of refractive index is to determine the degree to which the light bends when traveling from a vacuum to a medium. In other words, refractive index can be defined as the ratio of speed of light in vacuum to the speed of light in medium. The value of n is always more than or equal to 1. Here is the table of comparison between the refractive index of different materials such as air, water, glass, perspex, and diamond. It is obvious that different materials have different refractive indexes. What is the relationship between refractive index and optical density? When optical density increases, the value of refractive index N will increase. In the case of light travels from air to water, which is from low to high optical density, and obviously the optical density increases. The value of N increases from N equals to 1 to N equals to 1.33. So far okay students? Let's take a quick rest. Hi students! We need to know that according to the law of refraction of light, also known as Snell's law, when light travels from one medium to another, the incident ray, refracted ray, and normal line meet at one point and are in the same plane. Hence, we can define Snell's law as the value of n1 sin theta 1 is the same as n2 sin theta 2 for any mediums. Let's see the examples of Snell's law. In this diagram, we have water with N1 is equals to 1.33 and perspex with N2 is equals to 1.50. Incidence angle is 50 degree and refracted angle is 42.8 degree. To prove the Snell's law, we use the above equation. N1 sin theta 1 is equals to N2 sin theta 2. Substitute 1.33 sin 50 equals to 1.50 sin 42.8. The result is 1.02 equals to 1.02. Let's do some exercises. The first exercises, pause the video and do on your own. Alright, do you get the answers? It's just the same answers, 1.02. How about the second exercises? Pause the video and do on your own. The answer is still the same, right? Now that proves the Snell's law as the value of n1 sin theta 1 is the same as n2 sin theta 2 for any different mediums. Before we end our lesson, there is another case in which the light travels from air to any medium. Since index of refraction of air is 1, from the formula above, we substitute the second medium N2 with N, N1 with 1, theta 1 with I, and theta 2 with R. Hence, we get this final equation which is N equals to sin I over sin R. Do you understand, students? You have done your best. Good job! Doing a lot of exercise will help you in mastering this topic, okay? Refraction of light is purely fascinating phenomenon that occurs in our daily lives. Hence, do explore some other things or applications in our daily lives that involves refraction of light. Okay, students? Till we meet again next time in Let's Go Revision with Teacher Manisha. Bye-bye!